Testing. Testing. All right. Welcome to the geometry review for finals. I'm going to go over all the old tests. Plus, I put in here a test that I borrowed from another teacher that might help you cover some things that we didn't get to test on chapter 13. So I'm going to start off with chapter 12. Let me just try to zoom in a little bit. Okay. All right. So first off, which quadrant in 310 degrees is in? So to check that, this is the quadrants. 1, 2, 3, 4. And you always start at the right x-axis and go around. Now, one quadrant is 90 degrees. So this is 90, 180, 270, 310 should be here. So 310 is in the fourth quadrant. And then the second part is name two angles that are coterminal. So coterminal means it kind of ends at the same place, but it could go another loop around. So to do that quickly, all you do is do 310 plus 360. That's going to be 670. And I'm going to do 310 minus 360. That's going to be negative 50 degrees. So both negative 50 degrees and 607 degrees are coterminal. Next one. Express 47 degrees, 36 minutes to the nearest hundredth of the degree. Now, I remember people got tripped up on this question because it was like a perfectly flat number. You didn't have to round the decimal, and people really thought they had to round. Don't worry about that. So the nearest hundredth of the degree. So how this works is you have 47 degrees. So that's okay. We don't care about that much. But over here, every minute is 36 minutes out of 60 minutes in a degree. So I do 36 divided by 60, and I get 0.6. So that equals 0.6, and I just add those two pieces together. So 47.6. Now the reverse one. Express that into degrees, minutes, and seconds to the nearest second. Probably should say whole second. So 63 again degrees. That's good for us. Now to get 0.48 as minutes, and let me just make sure in the textbook because I don't want to give you guys false information. All right. So in order to do it, what you're going to do is multiply what your decimals here, which is 0.48, and times that by 60, because there's 60 minutes in a degree. So 63 degrees plus 0.48 times 60 is 28.2. So that would be in minutes. But because I have that 0.2, I'm going to move it over here. And then times that one by 60 to get my seconds, because there's 60 seconds in 1 minute. And 0.2 times 60 is 12. So that is 63 degrees plus 28 minutes plus 12 seconds. And I guess the final answer, I wouldn't put the plus signs in there. And 12 second minutes. Okay. Number 4. What is the reference angle to 800 degrees? Reference angle is the angle, let me do it like this, the angle that we refer to based off of 360 only. So what you do is find a coterminal angle between 0 and 360. So I'm going to subtract 360 here, and that's going to give me 440. Now 440 is not between 0 and 360, so I'm going to subtract another 360 here. So that's 80 degrees. Because it's in this quadrant here, oh, this is how it works, remember? Theta, and this is this angle here. Let me just draw these. Theta here, which this is going to be 180 degrees minus theta. This is going to be theta plus 180 degrees. And this one is going to be, the reference angle here would be, this would be theta minus 360. Okay? So since 80 degrees land here, we don't have to do anything special, so 80 degrees is our reference angle. When the angle is in the standard position, the terminal sides pass through 12,5. Find the 6 trigonometry functions in theta. So, when the angle's in standard position, so it's an angle that has one line here and one line along this way, where theta is going to come from this side. So it goes to 12,5. So it goes up 12, let's say 5, 10, 15. And okay, and then he goes 5 down, so 5 and 12 high. I'm sorry, so let me rewrite that. It goes 5, it's 12, 5, so you go 12 to the right and 5 up. I made a mistake there. Good thing I'm using a pencil. So it goes 5 up, and then 5, 10, 15, so 12 to the right. So what's so important about this? Well, this thing makes a triangle, a right triangle particularly, with 5 as is here and 12 here. Now when I talk about the theta, it's always going to be coming from the origin, so it'll be this angle here. Now to find this one, you're going to do 5 squared plus 12 squared equals x squared to find the third one, Pythagorean theorem. But I know this is the Pythagorean triple, so I'm just going to put 13. You could check it yourself if you want to. I'll just do it myself so I don't make a mistake. It is for sure 13. Okay, so what are we going to do there? So if this is 13, now I want the 6 trig functions. So we have sine, cosine, and tangent. Okay, those are our basic ones. And what we're going to use for sine, cosine, tangent is SOHCAHTOA. And when I say SOHCAHTOA, that means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over hypotenuse, adjacent, I'm sorry. So let's look based off this angle here. Sine is opposite over hypotenuse, so that's 5 over 13. Cosine is adjacent over hypotenuse, so that's 12 over 13. And tangent is adjacent, that's the one next to here, that's not the hypotenuse, which happens to be 12. And you can kind of look at this triangle if you can't see that clearly. I'm sorry, opposite, so it's 5 over 12. So opposite of the angle here, which is 5, adjacent to the angle here, which is 12. But it said 6 trig functions, so what we have to do is not only use the normal trig function, we're going to also use the inverse trig function. The opposite of sine is cosecant. The opposite of cosine is secant. And the opposite of tangent is cotangent. Remember, each one has to have a co to it, so each pairing. So to find the opposite, all you have to do is flip it. 13 over 5, because it was 5 over 13 here. 13 over 12, because it was 12 over 13 here. And 12 over 5, because it was 12 over 5 there. And that's it. That's my 6 trig functions for that type of triangle. All right, find the missing sides of the right angle if A is 30 degrees and C is 16. So A is 30 degrees. Now this is 90 and this is 30. 30 plus 90 minus 180 is going to be 60 degrees over here. So let's get the freebie out of the way. And is C equals 16, so this one equals 16. And I'm looking for all the missing sides of angles. Oh, so I got missing angle here, which is 60 degrees. Let's find missing side here. So let's use this one since that's the one they gave us. I'm going to call this theta. So I need the opposite and the hypotenuse of 30 degrees. Well, the opposite and the hypotenuse of 30 degrees is going to involve SOHCAHTOA, so sine, because it's opposite and hypotenuse. So the sine of 30 degrees equals, we have opposite, which is going to be a, lowercase a, over the hypotenuse, which we actually know the value is 16. So I'm going to times 16 on both sides. So 16 times sine of 30 degrees equals a. So if you look at here, you could always, first off, before you do anything, make sure you click mode and make sure you're in the degree mode, degrees. Okay? So we're going to do sine of 30 times 16, and we're going to get 8.47. So A equals 8.47, or actually 48 to round it properly. Now, what's important to know is that 30 degrees is a special angle. Sine of 30 happens to be, let me just think about it. It is, I think, root 3 over 2, or something along those lines. So if I remember correctly, I'll make the special right triangles later. But you could just type this into your calculator. And for the whole test, you'll have your calculator, so you could always type it in. You don't have to sweat the non-calculator sections. Let's get B. So this is 8.45, 48. To get B, what we're going to do is we're going to find the, I'll still use 30 degrees. So adjacent and hypotenuse, so that's cosine. So cosine of 30 degrees equals B over 16. I'm going to times 16 on both sides. So 16 times cosine 30 degrees equals B. So that's going to be 16 times cosine 30, which is this in the right mode? Yeah. Which is B equals 13.85. 13.85. Okay? Next one. Given that you know cosine of theta is 3/5 of a triangle, find the other 5 trig functions. So I'm going to make a generic right triangle with some generic theta. If I know cosine equals 3/5, I know adjacent over hypotenuse is 3/5. So I know my adjacent side is 3 and my hypotenuse is 5. Now I need to do the Pythagorean theorem to find this one. So that's 3 squared plus x squared equals 5 squared. If you remember your Pythagorean triples, this is just going to be 4. If you're not sure, you could check it by doing a squared plus b squared equals c squared. All right, so it's pretty easy. We have cosine already, so we need sine and tangent. Sine is opposite over hypotenuse, so that's 4 over 5. And tangent is opposite over adjacent, so 4 over 3. Well, we need the other 5, so we need the inverses, so cosecant. Secant. Secant is opposite of cosine. I didn't write cosine because we already have it. And our last one is cotangent. So cosecant is just the flip of this, which is 5 over 4. Secant is going to be the flip of cosine, which is 5 over 3. And cotangent is going to be the flip of tangent, which is 3 over 4. Okay, circle that. We're done. Go to the next one. Find the exact values of 225. Now, I could use the calculator to do this, but what I'm going to use it is no calculator because in a multiple choice, it's going to look like the square root things over the normal things. So what I always like to do is make it when I need it, the unit circle. So I'm going to go 90, 180, 225. So I want this reference angle here. So I'm going to do 225 minus 180. That's going to give me 225 minus 180. That should give me 45? Yeah, 45. Okay, so this triangle looks like this, kind of upside down on the bottom left of the quadrant. We know this is theta. And since this is a unit circle, it's going to be, we could call this a 1 right here. All right. If that one's 1, and this is, actually I know what theta is, which is 45, and this is 45. We have to look at our old 45, 45, 90 triangles. Our 45, 45, 90 triangle is x, x, x root 2. So if 1 equals root x root 2, I have to divide root 2 on both sides. But I can't have a root 2 on the bottom, so I have to multiply the top and the bottom by root 2. So your final part here is x equals root 2 over 2. So if this equals root 2 over 2, and this equals root 2 over 2. Okay? So the unit circle helps you a lot because when I'm looking for the 6 trig functions, and maybe I should point this out, since I'm going bottom left, that means my y is negative. So this is a negative root 2 over 2. And if you remember, maybe this is something you remember, all students take calculus, and this one's negative 2. That means that only tangent and its opposite, cotangent, is going to be positive. So let's solve it. First, we're going to start off with sine. Now, sine is from this angle here, so katoa, so opposite over adjacent. So opposite over hypotenuse, I'm sorry. So that's root 2 over 2 divided by 1. Anything divided by 1 is just root 2 over 2. Don't forget the negative. Cosine is going to be negative adjacent, which is negative root 2 over 2 divided by 1. So that's negative root 2 over 2. And tangent is going to be adjacent over hypotenuse. Now, adjacent and hypotenuse is exactly the same number, so it's just going to be, it's divided by itself, which is 1. So let's keep going. So we're going to use secant. No, I'm sorry. First thing we're going to do is cosecant, because that's the opposite sign. So cosecant, that is going to be the reciprocal of that. So it'll be 2 divided by root 2, and we don't want root 2's on the bottom, so we'll multiply the top by root 2. So we got 2 root 2 over 2, which reduces down to negative root 2. Secant here also reduces to negative root 2. Cotangent here is just going to be 1 again. Let's go on to the next one. Find the exact value of the 6 trig functions for 120. Okay, so let's find that reference angle. So 90, a little bit past that. So this is the angle here. Oh no, I'm sorry. It's the angle here. So to get that angle, how do we get that angle again? It would be I know it's 60, but how do you do it? 180 minus 120. That's right, 180 goes in front. So 180 minus 20 is going to be 60 degrees. So the reference angle here is 60 degrees. So it kind of looks like a triangle like this. Again, I will do the formation of the unit triangle with 60 degrees this time and 30 degrees. because if this is 60 degrees and theta, this is also 30 degrees. So if you don't remember your special right triangles, here's a little reminder. Opposite of 30 is x, hypotenuse is 2x, and across 60 is x root 3. So cos 60 is x root 3, yeah. Okay, so I have 60 degrees here, and I know this should be 1. My unit triangle from the unit circle is 1. So what I'm going to do is take 1 and divide it by, here, if 2x equals 1, then divided by 2 on both sides, x equals 1/2. So I know over here across the 30 is 1/2. And then over here, if x equals 1/2, x root 3 is going to be root 3 divided by 2, or root 3.5. Okay? Now we have that, we can make our 6 trig functions: sine, cosine, tangent. And the reason I mention or I show these instead of just using the calculator is because in your multiple choice section, your answer is going to look like this. It's not going to look like a decimal. So that's why I'm taking my time to do this way. Okay, so sine is going to be opposite over hypotenuse. If we're doing sine of 60 degrees, right? So opposite over hypotenuse. So that's root 3 over 2. Cosine is going to be adjacent, 1/2. And tangent is going to be the one divided by the other. So that is TOA, so opposite over adjacent. So root 3 divided by 2 divided by 1/2. That's the same thing as multiplying by 2. So that crosses out, it's just root 3. Okay. Then we have to do the inverses. So we can't, so when we invert this one, we have to multiply the root 3 on top. So it's 2 root 3 over 3. For cosine, you'd flip that really, or cosine's opposite, which is secant. That's real easy, that's just 2. And then cotangent, again, you can't have a square root on the bottom, so that's just going to be root 3 over 3. Now I want to point this out very importantly. I mentioned it when we learned this. Notice how the x represents the cosine and the y represents the sine. Over here, the sine is your y-axis, so sine is y. So that's root 3 over t, when you use the unit triangle, of course. Cosine is your x, 1/2, exactly. Tangent is going to be, so you have to do the opposite over adjacent, or you could say sine over cosine. Okay, and that's important later for trigs. Oh, and one thing I don't want to forget, all students take calculus or calculators if you want to be more fair. Students, that means the signs are positive, so I just make cosines positive, negative, and tangent negative. Now my answer is complete. We spent a lot of time just doing one test. But let's try to see if we can speed this. But this is tough, so it's unlikely. So we have to remember our law of sines and the law of cosines. Luckily, you're studying and you're practicing that. I'm not going to make any promises, especially recorded, if we do or do not get the equations. So I'm not going to make those promises right now. So let's see if we could do this. The law of, let's do this one first. So when you make a triangle, it's A, B, C. Now what's always opposite of it is the letter that it is. So if A, capital A is here, it's lowercase a. If capital B is here, opposite is lowercase b. And capital C here is lowercase c. All right, so if I know this is 120 degrees, and I know this is, A is 10, and B is 8, find angle C. Now the problem with this one is that we don't know if this is a right angle, or we don't know if A is a right angle. So we can't use trigonometry, or we can't use Pythagorean theorem either, because we don't have the proof for that. So what we're forced to do is something called law of sines or law of cosines. Now, you use, if I remember my rule from the one I told you, you use law cosine when you have angles and the two sides adjacent to it. And since I have the angle plus the two sides adjacent to it, I don't have a angle and a side pairing. I have to use law of cosines, which is typically the harder one. So let's see if we can solve this out. C squared, I'll write the equation, equals a squared plus b squared minus 2ac? No, 2ab, I'm sorry. Cosine, of course. Cosine C, capital C. Now you could switch this for any letter, just like if you put A here and C here, it'd just be a C inside here and an A in here. If you put B here and you put C here, you put C here, and you put capital B there. But let's plug it all in. So C squared equals 10 squared plus 8 squared minus 2 times 8 times 10 times cosine of this angle, which is 120 degrees. So I'm going to type that all in. 10 squared times, plus 8 squared minus, and I'm going to put the minus in parentheses so there's no confusion, 2 times 8 times 10 times cosine of 120 degrees. So I get C squared equals 244. Square root 244. So I get, it's a square root of 244, which I might, so I haven't decided whether I'm going to put it like this. I'm going to put it in the factored answer. So the square root of 244 divided by 4 is 4 and 61. 2 and 2, 61 is 1, 2, 3, 5, 7. Nope. So that's prime. So your prime factors, that'll be 2 root 61. Or I'll write your answer as a decimal, which I think was 15.62. Okay. So I might write your answer as either way. Just make sure you know them all. Okay, next one. If A, B, and C equals all that, find angle C. So again, make the triangle, capital A, capital B, capital C. Little a, little b, little c. Now I'll try to avoid making you have to make your own triangle on the geometry test, but sometimes it might be easier for me just to write it like this instead of making a triangle each time for you guys. So I know A equals 5, I know B equals 11, I know C equals 7. Find this angle here. Now for this one, what's useful is I can use the law of sines. And the law of sines is really easy because all you have to do is some cross multiplication and maybe some inverse trig. So let me just check my law of sines thing. So sine A over A equals sine B over B, yeah. So I'm going to use this. First I need to do this, so I'm going to do sine of capital C over lowercase c, which is 7, equals, now I have to choose one of these. Let's see. Oh, wait, I don't have angles, actually. Oh, yeah, I don't have angles, so I can't use the law of sines. I don't have any angle or siding pair. And since I don't have like a pairing, I have to use law of cosines. So let me use law of cosines. Since I'm looking for angle C, I'm going to do the same equation. C squared equals A squared plus B squared minus 2AB cosine C. Now, if you feel comfortable, plug in all the numbers first and then solve. For what I'm going to do is try to algebraically move everything first. So what I'm going to do is subtract A squared and subtract B squared from both sides. So I'm going to have C squared minus A squared minus B squared. Then I'm going to divide this negative 2AB to both sides. Negative 2AB. I'm going to set that equal to cosine C. So I'm going to find this first separately. Now I don't remember which way I taught it, so I might have just told you to plug it in and solve it with numbers. But if you do it like that, or you do it algebraically first, that's fine. Oh, let me plug in the numbers for you guys. So 7 squared minus 5 squared minus 11 squared divided by 2 times 5 times 7 equals cosine of capital C. So 7 squared minus 5 squared minus 11 squared. Then that thing divided by 2 times 5 times 7, which is 1070. I end up getting something like negative 1.385. 86 if I round it. Equals cosine of C. Now to get rid of the cosine from C, you have to use inverse cosine. So cosine -1. And inverse cosine here, so cosine -1. So I'm going to type that into a calculator like this. Second cosine, and I'm going to click second answer to make my life easier. Or you could retype in -0.3. For some reason I got a domain error, so that's going to be an issue. Let's see if I did something wrong. Because it shouldn't be bigger than 1, I know that. Hopefully I didn't forget something. That would be a shame if I did. This wouldn't be a good video if I did. Well, cosines is -2ab. Did I forget something? No, I subtract A, I subtract B. Oh, I forgot what I did. So I'll tell you what I did. I forgot to divide by -70. So that should be a positive 1.38. So that should be a positive 1.38 because it's -2 times A times B. If you saw that earlier in the video, I'm sorry if you got frustrated and you couldn't tell me. So if you saw that, then you're going to fix that by just doing second cosine again. It's in the glare. Second cosine, second answer. Now I still got a domain function, so that's going to be even a bigger problem. Why is this causing issues? I apologize. I'll send out another video in order to figure out what is the issue here. Or I'll do another video in order to solve this issue. Because unless I gave numbers that were impossible, which I don't think I did. No, those numbers are impossible. Yeah. Let me check this style. So let's do 5 squared plus 11 squared minus 7 squared. 7 equals 97. Divided by 2ab. I'm gonna have to skip that for now because for whatever reason I cannot find a solution to this. I'll try to look it up later. I'll leave myself a note on this piece of paper later. Number 2 on 12.5 to 12.8. Sorry about that, guys. All right, let's go to the next one then. This one's not completed, so we'll figure out what the issue is there. I'm sure I'm making a mistake. Maybe somebody sees the mistake and I don't see it. So we'll try later, okay? Points. No, it should be between 1, yeah. Okay. Emergency alert, it's about to flood apparently, again. All right, so let's make another triangle. A, B, C, 60, 65, and I'm just gonna throw this in. It's gonna be 65 plus 60 minus 180. This is gonna be 55. And then A is gonna be 7, capital, a little c and little b, and I'm looking for little b. So what I'm gonna do is law of sines. Now law of sines is a proportion. So sine of the angle B over little b equals sine of the angle, since I know what A is, I'm going to do angle A over little a. Now you could put the sides on the top and then the angles on the bottom, doesn't matter. So why don't we just plug all this in? So we have sine of 55 over B, I don't know what B is, equals sine of capital A, which is, I know what capital A is, which is 60, over, I know what the A is, which is 7. So what I'm going to do is some cross multiplication. So I'm going to do 7 times sine 55 divided by sine 60. So my answer for little b, and it should be smaller. Here's a little help to check yourself. If this is 60 degrees and this is 55 degrees, this should be smaller than this. And I got 6.62. So little b equals 6.62. Okay. Let's go on to the next one. A, B, C, and my thing got defocused. A, B, C, A, B, and A. So almost the same type of triangle. This time I know the angle is 30 only. I know the side is 11. And I know little b over here, little b over here is 9. And I don't know this thing. So what I'm going to do is put it again into the law of sines. This time I'll put the sides on top because I'm looking for or let's see. This time I'll put the, that doesn't matter which one I put on top. Let me put the sine again on top. So sine of 30 degrees over 11 equals sine of capital B, which I don't know, over 9. So I'm going to cross multiply. So I'm going to do times 9, then divided by 11. So 9 times sine, did I say 30 degrees? Oh, that makes it easier. 30 degrees divided by 11. So we get to that point. Now I need sine of b. So it's actually 0.409 equals sine of b. So in order to get rid of sine of b, I have to use inverse sine. So inverse sine of whatever I had before, this is going to be 24.14 degrees. Which makes sense because if this side is smaller, this angle should be smaller. All right, let's finish the last one. A is 31, little c is 50, and little a is 46. This time I'll practice not drawing the triangle to see if I set it up correctly. So I know sine of angle A, I know what sine of angle A is, which is 31 degrees, over the side of A, which is 46, equals the sine of angle C, which I don't know, over 50, which I do know. Okay, little c, which is 50. So again, a little bit of cross multiplication. 50 times sine 31 divided by 46. That's going to be that. Then I have to do an inverse sine for that answer. So my final answer there is 34.04 degrees. Okay, word problems. Don't be surprised when you see these on your final. A knight sees a princess on top of the tower at angle of elevation at 54 degrees. If the tower is 381 feet tall, how far does the knight have to run to get to the base of the tower? So So we have our tower of our princess. And then we have our knight. Now we know that the angle of elevation, so that's him looking up, is at 54 degrees. We know, let's say we pretend that the tower is straight up. And let's say what else we know. We know the whole tower is 381 feet. So we're trying to figure out how far he has to run, which is over here, x, to get to the base of the tower, to be particular, to get to the base of the tower. So 54 degrees, this is 381 feet, and this is x. So this looks like one of these problems over here. Since I have an angle and side pairing, I could do law of sines. So sine of 54 degrees. Oh wait, this is a right angle. Who cares about law of sines when it's a right angle? If it's a right angle, I could do SOHCAHTOA. So this is opposite and this is adjacent. So since this is opposite and this is adjacent, that's going to be TOA. So tangent of the degrees, which is 54 degrees, equals opposite, which is 381, over x. Times x divided by tangent. So that is 381 divided by tan 54, opposite over adjacent, yep, equals x. Type that in. 381 divided by tan 54 equals 276.8. So 276.81 feet. So that's this distance. That's how much he has to run just to get to the door of the tower. Okay. Two angles of a triangle is 71 and 48. The longest side is 64. How long is the shortest side? So let's make a triangle. So if this one, let's say, is 71 degrees, and say this one's 48 degrees, we could find the other one by doing 180 minus 71 minus 48. So that's 61. We know the longest side is 64, so the longest side is going to be across the longest angle. So this is 64 meters. We want the shortest side. So the shortest side is going to be across the smallest angle, which is this one. Now we have to do some law of sines. So sine of 71 over 64 equals sine of 48 over x. Cross multiply. You could have put it where your sides are on top. And if you did that, all you have to do is multiply sine 48 on both sides. But because I did it, I'm just going to do cross multiplication. Honestly, if you did do it the way I mentioned, like verbally, you'll still type it in the same thing in the calculator. So let's cross multiply. So 64 times sine 48, make sure to close the parenthesis, divided by sine 71. So we got 50.3. So it's 50.30 meters in this case. Again, symbolism doesn't matter. I'll let it focus so you can see the work. There you go. Okay, so cross multiply and type that in. Next one. Oh, this one, I like this one a lot. Two planes leave the airport at the same time. One flying at 300 kilometers an hour, another at 420 kilometers per hour. The angle between the flight paths is 68 degrees. So after 4 hours, where are they? So plane 1 goes this way. Plane 2 goes this way. Between the angle is 68 degrees. Now it's 300 kilometers per hour after 4 hours. So we're going to do 300 times 4, which is 1,200 kilometers. Because after 4 hours, they went 1,200 kilometers. And over here, you did 420 kilometers over 4 hours. So 420 times 4 should be 1,680 kilometers. So what we're looking for is this distance here, because we want to see how physically far apart they are. Since we do not have an angle/side pairing, because we don't have any of that, what we're going to have to do is log cosines. So I'll do x squared plus, x squared equals a squared plus b squared, so 1200 squared minus, plus 1680 squared minus 2 times 1200 times 1680 times cosine of that angle, which I know is 68 degrees. Let's type that all in. So we have 1200 squared plus 1680 squared minus, and I put this all in parentheses to avoid any problems, 2 times 1200 times 1680 times cosine of 68. Enter all that. So I get that number, but I don't want actually that number. I want the square root of that number because x squared equals that. So second square root, my second answer, I'm going to get x equals 1658. So 1,658.91 kilometers. All right, let's keep going. Triangle with the side lengths of 20, 33, and 65. Find the area of the triangle. So this one with the side lengths of 20, 33, and 65. This one I definitely don't remember offhand, so let me just flip over and get to it. This would be in your packet, I believe, that I gave you for your homework would be in 12.9. So if you're given two sides, no, I'm given three sides, I have to do the area equals the square root of s, s minus a, s minus b, and s minus c. And s is equal to 1/2 of the perimeter. So let's find the perimeter. So that the perimeter will be pretty easy to find. 20 plus 33 plus 65 divided by 2. Is this a triangle that's possible? Oh, this triangle's not possible because it's 20, 33, and 65. And 20 plus 33 is 53, which is smaller than 65. So because of that, let me just change this to, let's change this to 50. Okay? So let's change this to 50. So it's actually possible. I feel like I remember that problem occurring when we were doing it. So let me just start again. 20 plus 33 plus 50 equals 103. Divided by 2 equals 51.5. All right, to find the perimeter of this triangle, we're going to do the square root of 51.5, parenthesis 20 minus 51.5, minus 30 minus 33 minus 51.5, times, I should say, 50 minus 51.5. This is making a negative. Oh, I'm supposed to flip those over, so put those in front. I'll type it in correctly, though. So the second square root of 51.5 times 51.5 minus 20 times 51.5 minus 33 times, now I could do these in my head, like 51.5 minus 20 is 31.5, but I know in the finals you'll be stressed out and you're going to be working a lot on this, so there's no reason, to risk things like doing it in your head. So that answer is 212, so that's 212 0.17 units squared, because I didn't give a unit for that. Okay, let's get the next one. Another area question. With the side lengths of 9 and 13 and the angles of 70 degrees. Oh, find the area of this. Okay, so a triangle with the area in between being 70 degrees, the side lengths being 9 and 13. So let's solve that. The one that when you use the area angle in between is super easy actually, is 1/2 BC sine capital A. So 1/2 times 9 times 13 times sine 70 degrees. That's easy to type in. I just put 0.5 instead of 9. So 0.5 times 9 times 13 times sine 70. I got 54.97. Since I gave a meter, centimeter squared. Next one, we have 43, 72, and 19. So triangle here, 43 degrees. And I'm sorry, this is 43 degrees. Across from it is 13, and some other angle is 72 degrees. So when you're given one where you don't have all the angles, oh, well, you could find the third angle. So let's find the third angle real quick. That's going to help us. 43 minus 72, 65. So there's 65 degrees here. Now, what you do is the one that you know the side of, it's going to be 1/2 a squared times sine of b, sine of c, divided by sine of a. So I actually know those numbers. 1/2 a squared is going to be 13 squared. So 1/2 times 13 squared, which is 169, over sine of 65 degrees. It doesn't matter if you said sine B or sine C is different. It doesn't really matter. Sine C is going to be 72 degrees. What's important is the bottom one is going to be the one that's across of A. So sine of 43 degrees. So 0.5 times 13 squared, I'll show you how I type it in. 0.5 times 13 squared times sine 65 times sine 72 divided by sine 43. 106.79. So that's 106.70, I guess 80 if you round it. 80, did I give units? No, so unit squared. Okay. All right, express your work in radians. We're in chapter 13, yay. So express your degrees in radians. So to do your radians, you want to leave it in terms of pi. It's 320 degrees times pi over 180. So try to simplify as much as possible to make your life a little easier. 32, 18, I'm going to reduce this by 2, so that's 9, and this is 16. Then I can't reduce anymore, so 16 pi over 9. Next one, let's express 7 pi over 7 pi over 4. In degrees. So instead of being pi over 180, when you do it to degrees, it's going to be 180. Think of you're churning into degrees, so degrees go on top, divided by pi. Pi's cancel out. Let's see, 4, I can reduce this by 1, and I can change this to 45. 7 times 45 should be 225. So 225, no, that's not right. Let me just do this. 7 times 45, 315, my fault. 315 degrees. Next one. A circular center angle has 120 degrees and a diameter of 10 degrees. With that in mind, let's find that arc length. So, The circular sector has a center angle of 120 degrees. So let's make that circle. So the inside angle is 120 degrees. And we know the diameter is 10. So if I know the diameter is 10, I know the radius is 5. What is the measure of the arc length? Now this feels like we did this in a recent chapter. This is why it's strange. Why do I feel familiar about this? This feels like we did this in a recent chapter, the last test we took. Oh, this is why. So there's a different, well, no, there's two ways to solve this, which is pretty interesting. You could do that proportional thing that we did in the recent chapter. I'm going to use the method that's for this test, which is S equals R and theta. Now, if I remember, some people were talking about how they were supposed to change this to radians, and they forgot to do that. So I'm going to change that to radians right now so I don't forget myself. 180 degrees over 1 times pi over 360. 1 and 3, so that's pi over 3. And I need my radius, which I turned already from 10 to 5. So S equals pi over 3 times 5. Your answer is 5 pi over 3. If you want that as a decimal, that would be 5 times 3.14 divided by 3. So about 5.23. Please remember, if you're going to use this method, use radians. But luckily, we learned something that does the same thing with the proportional one. And I'll do the proportional one when we get to the proportional part of the test. The area of the sector. To find the area of the sector, it was area equals 1/2 radius square theta. Now, I already changed my theta into degrees, or to radians. And I already changed my diameter into radius. So I can just plug this in. 1/2 times 25, that's 5 squared, times pi over 3. So let me just do this way. So that's 25 pi over 6, which if you want 25 pi over 6 is going to be, as a decimal, 13.808. I would like to take time to check if you could do the proportional way. Check if you want to try that to practice, to see if you get around the same answer. Again, because we're estimating a lot of things, it might not get around the same answer. Okay, find the values of 6 trig functions of 5 pi over 4. Oh, man. Whew. So 5 pi over 4, you got to remember what type of angle this is. So since you see a 4 here, you know we're talking about the 45-degree angles. So we're talking about the 45-degree angles. If you see a 1 over 6, you're talking about the 30-degree angles. And if you see a 1 over 3, you're talking about the 60-degree angles. I should say this is 1 over 4. Pi over 4, and pi on top of all these. So since I know it's a 45-degree angle, and since I already took time to explain how to find the unit circle for a 45-degree angle, this is going to be root 2 over 2. That's 1, and this is root 2 over 2. So sine, cosine, tangent, I already did this in detail in the previous part of this. So this is going to be root 2 over 2. I think it's actually almost the same question. And then 1. Cosecant, secant, and cotangent. And that's going to be root 2, 1. Now, what's important, though, is that I need 5 pi over 4 is a function on this. So 5 pi over 4, if I turn that to degrees, should be, I'm doing it in my head, 135 degrees. That would land over here. And all students, so only sine is positive. So I make my cosine and my tangent negative, and the secant and the cotangent negative. Funny enough, I feel like, I don't know, it felt like an hour ago maybe, but like the other video was right, or had it. Okay, if cosine x equals root 3 over 2 and 0 less than x less than root 2, find the value of x. So why is that important to know? I need to know this piece just to tell me if it's going to be in this quadrant, the all students take calculus. So I need to know is in this quadrant or this quadrant. Because it says 0 to root 2, 0's here. And if you don't remember pi root 2, if you change that to degrees, it's 90 degrees. So it's in this area. That's important to tell you your negatives. Okay, so if cosine is root 3 over 2, and it's 0 and pi over 2, find the value of x. Ooh. So we know cosine x equals root 3 over 2. So what we need to use is which one is it cosine 30, cosine 60, or cosine 45? Now in the multiple choice question, 100% I'm going to put 30, 60, 45, and probably my fourth option would be 90. You could cross out 90 right away, because 90s are whole numbers, so it's going to be either 1 or 0. 45, no. We just looked over here. 45, it can't be. So let's see if it's sine or is it cosine 30 or cosine 60. So make that unit triangle. 1. Let's do 30, 60 like this. So across 30 is 1/2, and across 60 is root 3 over 2. Now, since I'm looking for a cosine, I'm looking for which one is adjacent over hypotenuse. So adjacent over hypotenuse would get me root 3 over 2 divided by 1, which is root 3 over 2. Since that is what I'm looking for, the adjacent one would be the 30 degrees one. So your answer here would be 30 degrees, actually. So definitely in a multiple choice, keep that in mind. That's a good way to do a multiple choice strategy. Oh, okay. Determine if the function's even, odd, or neither. Oh, I hope I remember this, but I think I do. To check if it's even, odd, or even, odd, or neither, you plug in a positive one and you plug in a negative one. If they're the same, oh boy, I hope I remember this correctly, because I remember I was messing up when I taught it. I'm going to say if they were the same, they're even. Let me just check that real quick. If they're the same, they're even, and if they're negative inverses, they're odd. Oh, yeah, even, the same, odd. So let's check this out. So y equals negative 1 to the 4th power over negative 1. Well, negative 1 to the 4th power is a positive 1 divided by negative 1. So that is a negative 1. So that does match the original. So let's see if we put it in positive, if it works. 1 over to the 4th over 1 equals 1 over 1, which equals 1. So that matches. Actually, do we have to do the original one? Like a positive version? Oh, no, I don't have to do this. So at this point, you see that they're the same number. They have still negative 1, so that's even. What about this one? So y equals, so let's say f of x, I should say, f of negative 1 equals negative 1 squared times negative 1, the absolute value of negative 1. So negative 1 squared is a positive 1, and the absolute value of negative 1 is positive 1, so this is 1. So 1 is here, and I plugged in a negative 1. Since they're inverse, opposites, that would be odd. I hope I'm telling you the truth. I think so. Odd. Odds are opposites. That sounds like something I would have said. Where's evens opposites? So if it looks like this, odd function is f of negative x equals negative f of x. So a negative version of the function. I'll check this out later, okay? Because I don't want to make a mistake on that. So take my word for now, but I could be wrong. Not like I've never been wrong before. Okay, amplitude, period, graphs, and equations. All right. So these are not too bad, actually. So the period is just how high and low, or no, wait, the amplitude is how high and low goes. So how high it goes is 1, 2, 3, and it goes down 3. So your amplitude of this function is 3. The period of function is when does it repeat a full cycle. So it looks like the period is 1, 2, 3, 4. So the period of function is a whole number 4. It's really important to know, a whole number 4. If you start at top, you got to see when you get to the top again, which would have been from 1 to 3, which is still 4. Maybe you started from the bottom, so that's 1 to negative 3, that's still 4. So the distance between peak to peak is 4 still, or valley to valley, I guess. This is an example, and I could tell you this for sure because I could look right at the book and it tells me, God forbid, this is an example of a odd function. Yeah, it's an example of an odd function because this is negative and this is positive, so odd function. Now graph the equation. What's the equation for this graph? The equation for this graph is going to be, if it starts at, oh, this is how I remember I checked it. This is how I taught you guys. So plug in sine of 0. So sine of 0 should give you 0. No, sine of 0 should give you, 0. And sine of 1, or cosine of 1, equals 1. So which one does this look like it starts at? 0 or something not 0? Since this looks like it starts at 0, I'm going to say this is a sine function. So sine of, and what's inside of that function is going to be the period. Now to find the period, it's 2 pi over b. And we know the period is 4. And we know, this thing is 4. So we're going to multiply b on both sides. So we have 2 pi equals 4b. Then divided by 4 on both sides. So that's going to be 2 pi over 4, which I could reduce to pi over 2. So the inside here is going to be pi over 2. And then the outside here is just going to be the amplitude, which is 3. To remind you, is a sine 2 pi over b. Oh, this is a trip to memory lane. Okay, let's go to the next one. I forgot we didn't do vertical shifts here. I won't put it on the final. All right, up here, we could start it at the top. That tells me it's going to be a cosine. And if it's a cosine function, I also know that means it's going to be an even function. An even function. Even function. Yeah. So, well, let's go here first. The amplitude of the function, it goes up 1, 2, 1, 2. So it spreads out by 2, so it's 2. The period of the function, it repeats at, it looks like 4 pi. So your period's 4 pi. This graph is an example of a even or odd function. I mentioned earlier is even. And since we're starting at 2, it looks like a 2 of a cosine. And we want to figure out what this in here. So we got to do 2 pi over b equals, in this case, 4 pi. So we're going to do the same thing over, but this time when we do that, it's going to become just 1/2. Close parenthesis. Oh, I should be putting x here in the equation. Apologize. I should be putting x because there's secondary variable. So 1/2 x, and this is pi over 2x. Okay, let's do the next one, which is graphing. So let's graph 4 cosine 2x. So just how to tell my starting point, I'm going to do cosine of the starting point is of 2x. So I'm going to plug in a 0, I should say, times 0, 4. Now cosine of 2 times 0 is cosine of 0. Cosine of 0 is 1. So 4 times 1 equals 4. So I know the first point I need is 4 comma 0. And that's going to help me draw the rest. But let's do this. The amplitude. So the amplitude is just the number in front, which is 4. The max or min. So if you're starting at 0, you're going up 4 and down 4. So your max and min is positive 4 and negative 4. The period is going to be how long it's spread out. So if I figured out this is 2x, I'm going to plug in 2 here for b. So 2 pi over 2, because b is this letter here, bx, that's how it looks like. So 2 pi over 2, that's just pi. So the period's just pi. Okay? And then we're going to graph. So I'm going to start here. Some people did it like both ways this way. Some people only went this way. I'm just going to do this way. Actually, let me do both. Why am I going to be greedy? So I know I'm starting at 1, 2, 3, 4. And then 1, 2, 3, 4. I know it's not very clean, but you'll have your own graph. So 4 up here. So that's 4. I'm starting here. And I know that I need to repeat my period at, let's say, pi. And let's call this 2 pi. So by the time at pi, I should be back at the top. So I'm going to go down. I'm going to be at the bottom at here, which is pi over 2, which is halfway to pi. And I'm going to be back at the top at pi. Let me do it again, because I said I needed 2 periods for this question. Down to 4, and then back up to pi. And this should be a little lower, I guess. But if you get the general graph, I will give you full credit, okay? So 4 on top, 4 on bottom, or negative 4 on bottom. Waves like that. Oh, and let me just do it backwards. If you want to do it backwards, this will be negative pi over 2, and this will be negative pi. So you could have went down to the bottom at negative 2 over pi, and then over negative pi over 2, and the top like here. It's not the cleanest graph, but it's full credit, so that's what matters. I'm going to skip the part 2 test, and I'll do that as a separate video, just because I need to make sure I remember it clearly. Because some of the trick stuff I honestly don't remember very well, and that's my fault. Okay, so we're going to go right to chapter 8. And again, I'll do a separate video for that stuff. Put T in the box if it's always true, or a check mark. I know a lot of people put just check marks. So let's do one is both pairs of opposite sides are congruent. So both pairs of opposite sides. So this and this is congruent, and this is congruent. For parallelograms, that is always true. Rectangles, that's always true. Rhombuses, that's always true. Squares, that's always true. Trapezoids, that's actually never true. And kites, that would also be never true. Diagonals congruent. So what does that mean? That means that this diagonal line over here and this diagonal line over here, the whole line is congruent to this whole line. Not for every parallelogram, and not for every, oh, it is for every rectangle, but not for every rhombus, but it is for a square, because a square is underneath a rectangle. Only for isosceles trapezoids, that's true. And for kites, no. They have a proportion, but they do not have they're not equal. Diagonals are perpendicular, so that means these diagonal lines form a 90-degree angle. Now that's true for rhombuses and squares. Not true for all parallelograms. Like rectangles, that's not necessarily true. Not true for traps, but it is true for kites. Okay? Diagonals bisect one another. So what that means is that the diagonals here, that this piece is equal to each other and this piece is equal to each other. Doesn't necessarily mean the whole line is equal to each other, but only piece by piece. Now, forgive me if I made a mistake, but I'm thinking all the parallelograms, that's true. Let me just think about it. Yeah, that should be true for every parallelogram. It's not true for kites. And I don't believe that's true for trapezoids either. I guess I should have said isosceles trapezoid to make it more unique, but That's true for, is that true for isosceles trapezoids? I don't remember, but it's not true for every trapezoid, so. Consecutive angles are supplementary. So consecutive angles means that angle A and angle B are supplementary. Angle B and angle C is supplementary. Angle C and angle D is supplementary. So for a rectangle, it's 100% true. For a rhombus, is that true? The rhombus, the opposite angles are congruent. But do they make a supplementary angle? I think so. And squares are true, too, because it's a rectangle. Are supplementary. Yeah, that has to be true, actually. Yeah, that's true. So all parallelograms are true. For isosceles trapezoids, that could be... Well, that's not all the consecutive angles are true. And for kites, that's not true. Both pair of opposite angles are congruent. That's true for parallelograms and everything under the parallelogram thing. And only one set of parallel opposite angles are true. All right, some always, sometimes, nevers. Don't be surprised. It will be on your final. A rhombus is a quadrilateral. Now, let's just make the family tree here to help us out. So you have the quads as the king, or the grandfather of this. On here, you have the trapezoid. And underneath that is the isosceles trapezoid. Over here you have kites. They don't have any kids. Over here you have parallelograms. So then underneath parallelograms you have two children, rectangle and rhombuses. And in between those two parallelograms you make one perfect shape, which is the square. Sorry if the noise of the rain is coming in, but it's pouring down hard right now. I'm still in the school, so if you're in Livingston, I'm sorry. Try not to get flooded. Okay, and then here's the questions. If you go up, from down up, that is going to be, like if a rhombus is a parallelogram, that's always true. If you go from top down, so top down, it's like quad to parallelograms, that's sometimes true. And if you can't do either one in like one stroke, like you can't go to square to kite, that should be never true. Okay, so if you have to go both up and then down, or down and then up, that would be never true. Okay, so rhombus is a quadrilateral. So a rhombus is always a quadrilateral, so that's always true. A rectangle is a trapezoid. A rectangle is a trapezoid, that can never be true. A trapezoid is an isosceles trapezoid. Since you're going downwards, that is sometimes true. A parallelogram is a rectangle. Since you're going downwards, that's sometimes true. Not all parallelograms are rectangles, but all rectangles are parallelograms. A parallelogram, wait, what? Oh yeah, a parallelogram is a rectangle. A square is a rhombus. A square is a rhombus, that's always true. A rectangle is a square. A rectangle is a square, that's sometimes true. Okay, they will be always, sometimes, never on your tests. Probably like those, more likely. Find the sum of the interior angles. To find the sum of the interior angles, you gotta do this formula. The sum of the interior angles equals n minus 2 times 180. So how many sides does this have? This has 18 sides, minus 2 times 180. 18 minus 2 is 16 times 180. 16 times 180 equals 2,880. So 2,880. A heptagon, what's good about a heptagon is hexagon, heptagon, octagon, nonagon. So heptagon's 7-sided, so that's 7-sided gon. So 7 minus 2 times 180, 5 times 180, that's 900. I don't need to type that in. Okay. A regular dodecagon. Dodecagon is 12 sides, okay? So find the interior angle and exterior angle in each of the following polygons for a single interior angle. So first we want to find the sum So all the angles added up. So we're still going to do somewhat the same thing. N minus 2 times 180. 12 minus 2 is 10 times 180. So that's 1800. Now, each angle of a regular dodecagon, or any regular shape, is all equal to each other. So if 180 is the sum of them, I know each one is 1/12 of it. So I'm going to do 180 minus 1/12. 180 minus 1/12, not 180, 180, 1800 divided by 12 equals 150 degrees. So that's the interior. And the exterior is just a supplementary angle. So 180 minus 150 equals 30 degrees. That's the exterior. And then 30 times 12, I just gotta make sure, equals 360. Good. A regular 20gon. So 20-sided shape. 20 minus 2 is 18 times 1800. So 18 times 1800 equals 3240. Then divide that by 20. That should be, I'm smart enough, 162. I'm just going to type it in because for some reason I don't trust myself. 20, yeah, 162. So that's your interior angle. The reason I divide by 20, the reason I divide by 12 is because it's a 12-sided shape and a 20-sided shape. And then the exterior angle is 162 minus 180 equals 18. After doing this for too long, you have to just check with the calculator, simple things. All right, find the number of sides of the polygon given the sum of the angles. So I tell you the sum of the angles, which is 1980 in this case, equals n minus 2, 180. So what I got to do is multiply 1980, and I'm going to divide 180 on both sides. That should be, looking at it, 19? No, I'm sorry, 11. So 11 equals n minus 2. Add 2 to both sides. This is a 13gon. 2340 is 2,340 equals 180 n minus 2 divided by 180. So 2340 divided by 180 equals 13 equals n minus 2. Plus 2 on both sides, that's a 15gon. Okay. Let's go on to the next one. All right, solve for x. So in order to solve for x, we gotta first figure out what this all adds up to. This is a 1, 2, 3, 4, 5-sided shape. So 5 minus 2 times 180, 3 times 180 is going to be 540, 540. So we know this adds up to 540. So we have to do 94 plus 6x plus 112 plus 7x plus 8 plus 118. So we're going to put that all set equal to each other and solve this really long algebra question. So let me combine some like terms first. So 94 plus 112 plus 8 plus 118. So I have 332 here. Plus 6 times 7 is 13x equals 540. So 540 divided by 332 equals, oh, I'm sorry, not divided, subtracted by 332. Silly me. Subtract 332, subtract 332. That's going to be 208 equals 13x. Then take that divided by 13, x equals 16. So x equals 16, did I just say solve for x? Yeah, I just said solve for x, good. All right, the exterior side. Now, here's an important thing to remember. The exterior angles for any polygon always adds up to 360. I don't care if it's a 10-sided shape or a 1,000-sided shape, it always adds up to 360. And I feel like I remember people made that mistake. So let's add up all the angles. So that's 22x plus 1 plus 38 plus 13x plus 19x minus 2 plus 13x plus 55. I put a lot of x's in this one. Let's combine like terms when possible. So 22 plus 22x plus 13x plus 19x plus 13x, all that equals 67x. And then the 38 plus the, is that minus 2? Minus 2 plus a 55. That should be 91. Okay. So subtract 91 on both sides. 360 minus 91 equals 269. 67x divided by 67. Did I mess up something? 38 plus 55 minus 2 is 91. 22x. 22 plus 13 plus 13 plus 19 is 67. And 360 minus 91 equals 269. And divide that by 67 is not a full number. So I get 4.01 as my answer. I'm going to check this again later to see if this is correct. I don't want to hold up the video too long. Let's go to here. Okay, so this is a four-sided shape. So you could do it two ways. You could do this adds up to 180, or the whole thing adds up to 360. So I'm going to do the whole thing adds up to 360 just to minimize worry. 3x minus 17 plus 2x plus 2 plus 90 plus 90. Combine like terms when possible. So 90 plus 90 plus 2 plus or minus 17 is 5x plus 165 equals 360. Subtract 165 on both sides. 195 equals 5x. Divided by 5x should be 39. Divided by 5, I should say. X equals 39. Okay. I'm going to check if 20 was right. I might have made a mistake somewhere, but I can't see it right now. Okay, this one. Because of the information you're given, you know they're a parallelogram. Because you know they're a parallelogram, you know this and this is congruent. So 1/2 x plus 15 equals 2x minus 15. Minus 1/2 x plus 15 minus 1/2 x plus 15. I have 30 equals, that's going to be 1.5 x or 1.5 x. That's 3/2, divide that. That's going to be 20. So x equals 20. And I think I just say so for x. So, okay, kites. Kites are funny. So x is this one, and the kite, the ones that's in between the two sides, are going to be in between this one. So we know a whole kite adds up to 360. So 360, because it's a quadrilateral, it's four-sided. You could use that formula from before, 2 pages ago. Equals 89 plus 42 plus, I'm going to say 2x, because you have two x's here, x and x. So x plus x is 2x. 89 plus 42 equals 131, equals 360 plus 2x. 360 minus 131 equals I couldn't type it right. 360 minus 131 is 229 equals 2x. Divided by 2. Your answer is x equals 114.5. Now this one, because I know this is the same size and I know this is the same size, I know that this is a mid-segment. Now, the mid-segment is just the average of the two ends of a trapezoid. So when I say the average, there's one side plus the other side divided by 2 is going to equal 13. So a little bit more advanced algebra, but you guys can handle it. So 4x plus 10x is 14x, so I'm going to have 14x minus 2. I'm going to multiply 2 on both sides, so that gives me 36, not 36, oh my god, 26 here. Plus 2 on both sides, that's 14x equals 28. And divided by 2 on both sides, x, or divided by 14 on both sides, which is x equals 2. Okay. Okay, so we're looking for this one, I think. I imagine I put the x there for a reason. Now, what this tells me is because I can see that this is the same size and this is the same size, I know that angle T is perpendicular, or at point T is perpendicular. So this is a right angle. So I could do 3 squared plus 4 squared equals x squared. I'm going to tell you right now, that's a Pythagorean triple, which is 5. But if you don't know, 9 plus 16 equals 25. Divided by, or square root it is 5. Oh yeah, this one I remember a lot of people were worried about it. They were sweating this, but it's actually not that bad. I remember people were like, really had a tough time with this one. Okay, so let's find some things with the angles. So the diagonals of a rhombus, STUV, intersects at W. Now that's really significant. Because I told you it's a rhombus, you know something. You know that this is parallel and this is parallel because it's a parallelogram. And you also know that this is a trapezoid. And I can't draw it while looking at the camera. So this is a trapezoid. Or I'm sorry, this is a transversal. So if you know this is through the 1.8, you know this interior angle over here at STV is 31.8. So let's see, I know that for sure. Let's see, is there a STV? Was that one of my angles? Sadly, no, I didn't make it any interesting. But I also know since this is a rhombus, this is 17, so this is 17. Let me just pull up my facts for rhombuses. Let's see if I remember everything from it. So sometimes I just don't. This is, what's chapter 8? Rhombuses. They're parallel. What else do I know about the diagonals of a rhombus? Oh, because it's a rhombus. Okay, my instincts were right. This is a right angle, and this is a right angle. And this is a right angle, and this is a right angle. So all those angles are perpendicular. Since I also know that's a rhombus, and I know this is perpendicular, I know that this angle here has to be 90 minus 38.1.8 minus 180. So 180 minus 90 minus 31.8. So this angle here has to be, now let me make this shape a little bigger. I guess not to scale, but at least it's a little bigger here. So if this is 31.8, this one has to be 58.2. And this is 90. This is 17. Hey, now I have right angles, I could do trig. I could do a little bit of trig here. Oh, and also since since I know it's a rhombus, then I know this is also 58.2, which makes this 31.8, which makes this 31.8, which makes this 31.8. Oh, no, I'm sorry. Which makes this 58.2. You can figure it out by doing the minus 180 thing, or you can figure it out by alternating interior. 58.2 and 31.8. I gave you a lot of information just because it's a rhombus. Okay, we found these angles. We know this and this has to be the same because it's a parallelogram. I don't know what these sides are, and I don't know what the outsides are. But let's fill in these angles. UVS. So UVS is this whole angle. So 31.8 times 2 That whole angle is 63.6. TUV, that's the whole angle here. So that's the whole angle here, whole angle here. So 2UV is 58.2 times 2 is 116.4. TWU, so TWU, that's the inside, so that's 90 degrees. UW, so I imagine line UW I'm at. So UW is this line here. So what I gotta do is some trigonometry. So I'm looking for this line here. So let's see, I could use this one and have the adjacent and the opposite, well, TOA, so opposite over adjacent, yeah. So I'm looking for this side here. I'll use this one because what happens is if I do it like that, so tan of 1.8 equals opposite over adjacent. It puts my x on top. And the reason I want my x on top, it makes it easy because all I have to do is times 17, type it into my calculator. 17 times tan 31.8. So that should be 10.54. That sounds familiar to me. So maybe that is the right answer. So it's 10.54. SU, so SU has to be this whole diagonal line. So if this is 10.54, SU, which is the whole diagonal line, is going to be twice as much because for every parallelogram, this is congruent to that. So 10.54 times 2, the SU, yeah, SU. So that is going to be 21.08. NVT is 17 plus 17, so that's going to be 17 times 2, which is 34. Whew. And I'm just flipping through the book to make sure what I'm saying about parallelograms is true. Yes, it's true. It's true that the diagonals bisect each other. So that's true. Okay, so that's 24. Okay, or 34, I should say. All right, this one, WXYZ is a square. So whenever you make a shape, just go from like clockwise or something. Like you gotta go around the thing. Or another way to think of it, like if you drew it, you have to follow your pencil, okay? You never would draw like this. Like you never would make a square like that. Okay, so I know WX is, and this is a square, so I know the angles are 90, I know the opposites are equal. So I know this is 1 minus 10x, and this is YZ, 14 plus 3x. Oh yeah, and since I made it a square, I made it purposeful so no one could mistakenly write this. Or like, even if you drew it wrong, you still could get it. Now, I remember I did that actively. It used to be a rhombus or something. Or actually, I guess a rhombus wouldn't change. I think I made it a rectangle before. No, it had to be something. It was something that wasn't this easy. Like, it was mistake-proof, basically. But anyway. So we're going to set those equal to each other to find x. So 1 minus 10x equals 14 plus 3x. Am I getting a negative number? No, I shouldn't. So plus 10x minus 14 minus 14. Yeah, I'm getting a negative number. Why am I doing that? All right, well, either way. So minus 14 is 13 equals negative 13, I should say, equals 13x. So x equals negative 1. Oh, okay. Because x equals negative 1 doesn't necessarily mean the side is negative, so that's totally possible. Okay, that's why I was a little concerned. Yeah. Big X could be a negative. Doesn't matter because all I care about is the whole side being. So I'm going to plug negative 1 into the easier one here. So 1 minus negative 10 times negative 1. So that's going to be negative negative. That's 1 plus 10, and that's 11. So that's 11. And then we're looking for xy. Now, if it's a square, this is 11, and this is 11. You could plug a -1 here. So this is also 11. So your answer is 11. Solve for each. Okay, so are these parallelograms? Did I give enough information to say they're parallelograms? I guess I have to tell you these are parallelograms. So imagine I told you it's parallelograms. So you just set each diagonal equal to each other, equals 3x plus 6, minus 6 on both sides, divided by 3. So that's 6 equals 3x, x equals 2. And then for y, it's 2y plus 9 equals 27, minus 9 on both sides, 2y equals 18, divided by 2, y equals 9. Real easy points there. Over here, the opposite diagonal angles are equal to each other. Now notice this says x and this says xy, and this says 70 and 2x. So I have to find x first. So 70 equals 2x, 35 equals x. And then down here, I have x plus 3y equals 3x plus 5. So x plus 3y equals 3x plus 5. But I actually know what x is. It's 35. So I could plug in x here. So 35 plus 3y equals 3 times 35 is 105 plus 5. Subtract 35 on both sides. Oh, I could add this, so 110. Subtract 35 on both sides. 3y equals 75. Y equals 25. That number sounds familiar to me, so I hope that's correct. Oh, the extra credit. So I'll do this one, though. Extra credit, simplify as much as possible. This was that second test I showed you that I skipped over in this video, and I'll do a separate video for. So let's do that. Cosine, cosecant, and tangent. So cosine x, cosecant, remember, is the reciprocal of sine. So I'm going to times this as 1 over sine x times tangent is sine over cosine. So sine x over cosine x. Sine over cosine. And I'll give you a sheet with the trig identities. Well, this crosses out, and then this crosses out, so your answer was 1. Don't remember. I think there was only... Who got that one right? One person or 2 people got the extra credit. Man, I wish I could remember. I apologize. If you were the ones, I'm proud of you. Good job. Okay. Use the best name to describe all these things. Did I give you this type of test? I must have gave you this test. So, let's use the term that describes the best. Now, there's a bunch of things going on here. I think I made it more straightforward or more simple on your actual test. This is like a first draft or something. So let's see if this is so useful to look at. So let's look at this. At F, it's just a point here. So that's a point of tangent C. Because at the point is tangent. FE, so line FE, and this is with arrows. Line FE, since they share a tangent between 2 circles, that's a common tangent. I don't think I gave you this on your test because I didn't like this because it's like you need a word bank basically to give you the most accurate thing. So this is so useful for help, but I think your test might have been a little better. So come and bring me your old test if you have that, and I could do that. HG, this line segment HG is from the center to the edge, so there's a radius. DB, or is this is from like, I think it's like practice B worksheet. DB is a chord, and the reason it's a chord is because it stops at D and B. So that's a chord. C is center, because that's the center of a circle. BE goes through the center, so it's more than a chord, it's a diameter. DB continues, so DB all the way through. Since it goes outside the circle, it stops being a chord and becomes a secant. The arrows is a secant, while the line segment is a chord. AG should also be a common tangent. So I wonder, This is why I don't like this exact question, so don't expect a question like this. Expect a question in your actual test, chapter 10. I guess this is a different format used. I think I removed it at the end. So it's usually what I do is I have most of the things, and any last minute edits, they're saved somewhere else. So I must have printed out like an older version. Let's do the rest of the questions. Find C at the value of x. Assume the segment appears to be tangent. So this looks like a tangent, so I think it's a tangent, which means this is a right angle. So I know x, and I know this is 4. The reason I know this is 4, and I think this held up a lot of people, if this is 4, this radius is also 4. So it's 4 squared plus 8 squared equals 4 plus x squared. Now don't make the cardinal sin of distributing the 2. So that's 16 plus 64 equals 4 plus x, 4 plus x. If you had Kirsten last year, you guys should do that quickly. 16 plus 64 is 80 equals, I'm going to write it as x squared plus 8x plus 16 if you FOIL it out. Or if you remember the trick for a square, a perfect square. So subtract 16 on both sides. So I got 64 equals x squared plus 8x. What do I have to do here? Oh, subtract 64 on both sides. So 0 equals x squared plus 8x minus 64. Did I do something wrong? No, I think I'm doing it right. So factors of negative 64 that add up to positive 8. Let's see, factors of 64 that adds up to negative 8. Okay. Oh, that's what you did, yeah. 64 divided by x. Let's see. 8. I'm looking for 8. No, it can't be. What am I doing wrong? Did I forget something? What am I doing incorrectly here? Oh, did I give you a non-factorable one? That's what happened. I didn't give you a factorable one. So because I didn't give you a factorable one, it's not going to ever look good. So because of that, let me just check on my calculator to see if it's actually unfactorable. And I think I promised I wasn't going to give any unfactorable ones, so. Yeah, it's unfactorable. I wasn't going to give you any factorable ones, so I would have given you one that would work out. That's my fault, but the answer, if you use the quadratic equation, would have been 4.94. Again, I won't give you an unfactorable one. Yeah, this is definitely an old version of the test. Okay, 2x plus 13, 4x minus 8. So for this one, you could have set them equal to each other. So 2x plus 13 equals 4x minus 8, plus 8 minus 2x. 21 equals 2x. 10.5 equals x when you divide by 2. All right, this one. If this is 147 and this line equals the same, so you know this one's 147, and then a whole circle is going to be 360. A whole circle is 360, so I can subtract 147 twice, and I know this is 66. So I'm looking for the measurement. Yeah, this is definitely a bad version of the measurement of arc MN. Oh, I found that already, so that's 66. Just to reiterate, 360 minus 147 minus 147 end up being 66. Okay, this one. If zy is 6, so zy is 6, and xw is 4, what is this thing, I imagine? Wait, what? If zy, I can't read. If zy, so the whole thing is 6. If the whole thing is 6, this is 3 and this is 3. And you know that because this is perpendicular. And you know this is wx is 4. This is going to be a 3, 4, 5 triangle, so that's 5. If you don't know, 3 squared plus 4 squared equals x squared. If this is right angle, then this is also a right angle. All right, this one here. Okay, so this one you have to add and find the average to find this angle. So 142 plus 124 divided by 2, that should be... And I'm sorry I'm being really slow with the math. It's just, I'm on probably 2 hours right now, so I'm just going to be pretty weak in the math. So 133, like I'm going to be bad in the arithmetic. Then if this is 133 and this is a linear pair, I can subtract it from 180. So this x is going to equal 47 degrees. Let's keep going. If this outside is 93 and this is 65. Oh, this was a tricky one. This is more tricky than the one I gave you, but it's still useful. So first, I want to find this angle eventually, but I definitely need this arc. So to find the arc, and I'll just redraw it here, you could do, if this is this, and if I know this is 65 degrees and this is 93 degrees, I could find x. So I'm going to find x first here. So x plus 93 degrees divided by 2 equals 65. So 65 times 2 equals 130 minus 93 is going to be 223. Oh, I had it in accident. Minus 93 is going to be 37. So x equals 37. If that is 37, now what we could do is do 93. When the angle's on the outside, you subtract instead of add the average. So 93 minus 37 over 2. So 93 minus 37 divided by 2, that's going to give me 28 degrees. A little harder than I remember giving to you. All right, if this is 64, an angle that's inscribed, which is the angle on the side of the circle, it's going to be double this. So this one right here, this arc right here, if that's 64, then 64 times 2, this is 128 degrees. But I need the outside arc and the inside arc, so I need this bigger arc too. So I'm going to do 360 minus 128, and that's going to give me 232. So that gave me the bigger arc. 360 minus 128 equals 232. Okay, so that's that, and then we're going to do the subtraction thing. 232 minus 128 divided by 2. 8 divided by 2 equals 168. Okay. This one, I think this is the exact question I gave you. So this is 170 degrees. So what's this little piece right here? We don't know what this little piece is right here. But if we know this is 135 and we know this is 170, we could do 360 minus 170 minus 135. That's going to be 55 degrees on this arc, so that's a 55 degreer. And since this is the bigger arc on the outside, it's going to be 170 minus 55 divided by 2. That is going to be 57.5 degrees. Over here, find the value of x. So this is small piece versus plus times the whole piece. Was this factorable? I hope so. So 4 times the whole piece is 10 equals x times the whole piece is 7 plus x. So you have 40 equals 7x plus x squared. Let me rearrange that. So 0 equals 0 equals x squared minus 7 plus 7x minus 40. Now, no products of 40 add up. Yeah, no products of 40 does give you, sadly, does not give you 7. I can't think of one. 10 and negative 4, that would give you 6. Should have made this a 6. Well, that would have made it 4 then. I guess that wouldn't be unique. Yes, I forgot. These things were not factorable. Okay. I'm just going to do the quadratic equation in my calculator real quick to get the answer. Actually, I'm not doing the quadratic equation. Let me tell you what I'm doing. I'm graphing and then finding the 0 value. Do you remember that, guys? Like when you graphed it and found what 0 is on the quadratic equation, and that would give you the answer. So that x should equal 3.72, and I'm only including the positive one because the negative one would make the whole thing negative, and that wouldn't work. So that is that. Again, I will give you it so it's factorable, so I won't make that mistake. Okay, this one. It looks like I made this one, so find the value of x, assuming this is a tangent, of course. I should have said that. So 12x and 8, this is going to be x also. So it's 12 squared plus x squared equals x plus 8 squared, all squared. So that's 144 plus x squared equals, and I'm just going to do the trick, x squared plus double what this is, which is 16x, plus the square of 8, which is 64. Now, thankfully, the x squares cancel out each other. So minus x squared, minus x squared. And I'm going to subtract 64, subtract 64. So I have 16x equals 80. Oh my God. I'm definitely tired because I could do this faster, but doing this in a row is rough. So I sympathize with you guys who are studying. So divided by 16, x equals 5. So this is 5 and this is 5. And it makes sense. 5, 12, this whole thing is 13. So that makes sense. Okay, let's do this one. And some of you guys got 13, I will tell you this. Some of you guys figured out that this thing is 13, but since I was asking for 5, you had to get 5. So what you could have done is x squared plus 12 squared equals, well, I guess you needed to know that was 13 first. So I guess, I don't know how you guys got 13 without getting 5. Maybe you got 5, but you didn't realize it. So I'll look into an alternate method to solve this. This one is piece by piece. Piece times piece equals piece times piece. I think the answer here was 10, but let me just check. 1.6x equals 2.5 times 6.4. 2.5 times 6.4, I should know this, is 16. 1.6x equals 16 divided by 1.6x equals 10. Okay. This one, oh, this one tricked up some people. Wait, this one I think is unsolvable. Yes, this one is unsolvable because I need to give you some information like here. Like I give you this is like, yeah, I have to give you this information. I remember I had to change this in the last draft, so I added some numbers here. So this one was unsolvable, so don't worry about this one. Oh. Well, look at that. That seems to be it for our test. Is that really it? Why am I feel like I'm missing something? Oh, yes, I have to hand back the other test, so I couldn't even print that out yet. So next time we meet, which is Monday, I'll hand out the tests of the last one you took, answered, or it's already been corrected. Just had a student waiting to solve it. I hope this helped. I know I blundered a little bit during the trigonometry, and I have to look into the trigonometry again because I don't want to do that extra test, the one I gave you for practice, if I don't remember it all the way, or if I want you to do everything there, because maybe we only covered some of the things there. So I'll look at that carefully and tell you what's good or not. Otherwise, I hope you guys have a good time. Do all that normal stuff that you need to do. If you need any help, I'm always happy to help. Even if you want me to stay a little bit after school, I'm happy to help after school. Otherwise, good luck on your finals. I sympathize how much you guys study and work on it after doing this for 2 hours and seeing how fried my brain is. Good luck on your tests, and I'm here to help you no matter what.